This is the screencast for section 3.3, example 8. We are going to find second and higher order derivatives. So the second derivative, third derivative, fourth derivative, etc. And we express that like this. The nth derivative is d to the nth y over dx to the nth. So for example, in example 8, find the first four derivatives of y. Well, the first derivative, which we call dy dx, so the exponent in there is all 1, we'll use the power rule. So 3 down in front is 3x to the now second power, minus 2 times 5 is 10, x to the now first power, and then the derivative of a constant is 0, so we don't have to worry about that term. Now the second derivative is going to be d2y over dx squared. And then that derivative will be 3 times 2, which is 6x to the now first, and then minus the derivative of 10x, that's x to the first, so we bring 1 times 10 is still 10, and now it's x to the 0, so we don't have to write that. The third derivative, which we still say it as third derivative, but it's written like that, is going to be, let's see, 6x, the derivative, that's x to the first, so 1 times 6 is 6, x to the 1 minus 1 is now 0, and the derivative of 10 is 0, so that's it, it's just the constant 6. And then the fourth derivative, the derivative of a constant is 0. So what I did was I graphed these over here for you, and you can also write your derivatives as y prime, y double prime, y triple prime, etc. So we have y prime, so the derivative of y, the slopes of the tangents, so look, here's a horizontal tangent, here's a horizontal tangent, here's your 0, here's your zeros, and then y is decreasing, so y prime is negative. You can kind of see the relationships here. Now look here, this is y prime, so this is y double prime. Y double prime, the slopes are going to be negative and then change to positive, so negative and then change to positive, but now y double prime is linear. So y double prime has a constant slope. Its slope is always 6. This line has a slope of 6. Remember, it was 6x minus 10. So its slope is constant. So y triple prime is going to look like that. A horizontal line whose y value is always 6. Then its derivative, since it's a horizontal line, it always has slope 0 all the way across. So the fourth derivative is going to be the line y equals 0, and that is it. The now try problem number 33 says find the first four derivatives of the function. So we're going to do that. We're not going to graph it this time. I know that's not in the instructions, so we'll just find the first four derivatives. Y prime is 4x cubed plus 3x squared. Hopefully you're getting very quick at using the power rule. The second derivative is going to be 12x squared plus 6x minus 4. Derivative of 1 is 0. The third derivative is 24x now to the first plus 6. And then the fourth derivative is just 24. So that's a horizontal line. So if you can predict, the fifth derivative would be 0.